If you're into micro soldering and board level repair like I am, at some point you need to use a microscope. I use a digital microscope, and with my microscope, we get these types of lamps. These are just kind of lights that shine directly down. They attach to the end of the microscope onto the lens, and they shine directly onto what you want to magnify, what you want to look into, what you want to repair. And to be honest, they kind of suck. They're not that great. They have an issue, and that issue is glare. When I shine a light down, they shine a light right back at me. I think this is a good demonstration of the issue. This is a circuit board under my microscope with the pre-packaged lamps that came with the microscope. This is with a much better way of lighting. How do I do this? Is there a better way to do it? Well, this is just indirect lighting. I use something cheap, something that's not very expensive and that has issues. This is what I use. These lamps just clip to the side of my table. I can shine them on a circuit board while it's underneath my microscope, and it works. I would like to have something that is a bit higher quality, something I could move to different parts of my desk, something that has maybe longer gooseneck spotlights, something that doesn't shine a light in my eye if I see it off to the side, something that kind of stays where it should stay. But I do like the light. This is a lamp I found online. It has almost everything I want. It's got a big gooseneck lamps for a good spotlight. They're very movable. You can move it around the desk. I really kind of like this fader to turn up the brightness and turn down the brightness. I think that's something I'm going to have to go with. I bet I could find one of these if I just look around online and see where I can pick one up. This is from one of my favorite YouTube content creators, and I think this is a perfect way. 195? Nope, 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 nope. Okay, it's clear. I'm gonna have to build one myself. So check this out. This looks a lot like what I want to use. It's flexible. Looks like a gooseneck. I wonder if I could put a lamp inside of it. Well, I got one. It isn't the best of quality, but it does seem to do what I want it to do. It's kind of cheap plastic. I'm going to take these things apart and see if I can run some wire in them. Looks like the gooseneck itself is made out of metal and it's lined with rubber on the inside for water to flow, and it has some sort of like rubber coating on the outside. So I've always thought that there's a correlation between something that is smarter, better, higher quality, safer, and cheaper. And oftentimes, when you try to do things that are cheaper, you sacrifice all the other things. But I like things to be cheaper. I don't like to spend a lot of money on everything, and I kind of feel like when someone builds something purpose built and then they mass produce it and sell it to a bunch of people, they're not looking for it to be cheaper. They're looking to maximize profit, and sometimes they will skimp on safety, sometimes they skip on quality, and sometimes they take away some of the features. It's just not as good of a product as you want it to be. So I like to make my own stuff, and sometimes it's neither smarter, and sometimes it's not better. Sometimes forget it. I don't know why I make my own stuff sometimes, but the truth is, I've accepted truth about myself a long time ago, and that is that I will spend 100 hours so that I can save $20. It's not smart. It's what I do. In this case, though, what I found was this. These are uh, the little. I think you've seen the video now. I've added the video. Little things that are used for redirecting the flow of water. I ran some wire in them, but they stay where they're supposed to, and they seem like a nice way of doing things. There is a very similar product that is used for lamps. and the lamp version is just kind of a gooseneck. It doesn't have this kind of rubber on it. The thing with those is that the lamp version is like $18, and this is less than $3. And in fact, when I want to build things, what I realized is there are millions and millions and millions of pipes and plumbing supply pieces that are made and put into production in the world all the time. And the thing about that is that sometimes they are super high quality stainless steel parts, things that would probably cost 50 or $60 if they were custom built for a piece of electronics cost a dollar or two or less if they are already built as plumbing. And so the idea that I have with this is that I can build a better, smarter, cheaper product with common plumbing supplies so that I don't have to do a lot of retrofitting or rework just to make it all function. But I ran into an issue. Here's this, and it works. It bends, it stays in the shape I want it to for the most part. However, what happens when I put some weight on it? So the idea here is this is the end piece that would go on a faucet for an aerator. Fits on really nicely. This is a thin brass nut that has no purpose whatsoever. I just kind of like the way it looks. This is a stainless steel 20 millimeter to, I believe, 22 millimeter pipe fitting. And there it is. The idea is that inside this little piece, I'd have a lamp, or an LED, bright LED that would shine outward. We'll get into more of that later, but here's the problem. I attach this to the box that holds all the electronics for this. I let go. It's too heavy. It doesn't stay up. This is heavy. Oh, that's kind of an issue. So how do I stiffen it up? Well, I can think of two different possibilities. I can put a sheathing on the outside, some shrink wrap, on the outside of it that would give it more structural integrity, harder to bend. And I think I'm going to try that. So this is some heat shrink covering. Usually we go over a big electrical wire. It is thick and industrial. It has some adhesive built on the inside, and it's supposed to shrink to about one third of its current size when it's heated up. And I feel like if I can use this and then maybe put some transparent heat shrink on the top of it, with both of them together create enough of a kind of structural integrity to let this hold the weight. So let me just try to put these things together, and I'll use my hot air gun to melt or at least shrink the coating, and we'll give it a try. By the way, the idea is I can put my LED lamp right here, a lens to focus the light more, put it in place, and this part will act sort of as like a recessed lighting to help remove any glare or any light shining in my eyes. So I'll put this back in place, and this is kind of what it looks like. Not bad. I like it. All right. It's here. Ooh, ooh, that's not bad. That's really good. All right. All right. So I got a little dimmer controller. Um, and a few other pieces and parts here. This is just an LED that I'm going to use to test this out. And I'm going to use my adjustable power supply just to give it 5 volts of power and see if it works. Nice. Okay, I just want to go over the cost of all these different items. What you see before you is all of the pieces and components to make the microscope lamp. So I just wanted to go through them. The dimmer controller, roughly $1. Power supply, right here, $2. Toggle switch, 25 cents. The inlet plug, 50 cents. The lenses, and I could only buy these in packages of 10, cost $1.25. The various connectors that I'm going to use, including these, about $2. The dimmable 5-volt LEDs, 60 cents. And I could only get them in certain quantities, so there's a package of 4. I only need 2. The various plumbing parts and things that I'm going to use for the goosenecks, also the pieces to connect through the box. All of that is roughly $15, probably a little bit less than that. This box that I bought, a little do-it-yourself project box, was about $10. The various other components like heat shrink that I used around these goosenecks was $4. This bit of steel here was $1, and I'm using this to add extra weight and also to mount the electronics together in a way that I can have a nice ground, and I can also put it in the box in a kind of a modular way. The extra weight should do some good things for me. Power cable, $5. I just have one laying around. I'm just estimating the cost there. Miscellaneous hardware, the various screws and different things I'm using, it's around $5. It's probably a lot less than that, but just kind of guessing. Getting all these things, buying them separately, sending them off, took a lot of time. I'm going to guess the shipping was around $30.